All right, so integrated 2, chapter 4, day 3. Again, we're starting with the idea that we're going to be given a quadratic equation that we know will make a parabola, that kind of U shape. We're going to start with it in standard form, or like chapter 1, as a sum, and we're going to factor it into a product form so that we can get the x-intercept. So that's the goal. We haven't really done it yet. We've talked about it a couple times. Again, we have this 5-step process, at least in chapter 4. We're going to add some steps to it in chapter 5, where we'll just talk through one right now. So y equals x squared plus 6x plus 8. The first thing we're going to do is initial factoring if possible. Well, by the way, we're in the form y equals ax squared plus bx plus c. I don't think I've formally addressed that yet, and I probably should. So I know it showed up over here in standard form. That is the standard form. So the a term is going to be whatever is with the x squared. The b term is going to be whatever is with this x, and the c will be whatever is by itself. So for instance here, there's assumed to be a 1 in front of that x squared, so that would be your a. The 6 is with the x, so that would be the b. And the 8 is by itself, so that would be the c. You'll notice the a is not 1x squared, the b is not 6x. It is the coefficient or the number out front. And again, if there's no number out front, it's assumed to be a 1. So we're looking for that initial factoring, like the worksheet we just did. Is there a number that goes into 1, 6, and 8? And the answer would be no. 1 would be the smallest number, so we're not going to do anything to this. We're going to leave the problem the exact same. You can see over here, I'm not going to talk about this problem, but it was 4, 18, and 10. So I could have taken a 2 out, and I factored out the 2. So we'll talk about example 2 later as our problems get more problematic. But for right now, we're going to start with the simple one. So when we look here, we're now going to set up the diamond. So this is going to be our second step. Numbers are placed in the sides, need to multiply to the top and add to the bottom. So that's a little bit complicated. Let's look. First of all, when you set up this diamond, the first thing you're going to do is we're going to set up the top, the bottom, the top of the left, and the top of the right. And then what we'll do is we'll have to think about what goes in the bottom left and bottom right. So this is going to be our standard setup. So the first thing is the top is a times c, which is 1 times 8. So I'm going to put an 8 up there. The bottom is just whatever the b term is, and the b term is 6. So I fill the top and the bottom. Now I'm going to go over to the sides. I'm going to put whatever the a term is, x. Well, you can see there's 1x. So a is 1, so I'm just going to put 1x. And now we're going to go here. It says numbers placed in the sides need to multiply to the top and add to the bottom. So 4 times 2 equals 8, and 4 plus 2 equals 6. So I know I didn't talk about this one right here, but if you look, 10 times negative 1 equals negative 10. 10 minus 1 equals 9. So that's how that's going to work. And hopefully you've been doing your homework the last several years and you've seen these diamond problems a lot over the years. Maybe you haven't seen the tops of the sides, but the rest of it you should have definitely seen. So now the book's been trying to get you to practice that stuff so now that we know what's going on. Now we're going to simplify the sides of the fractions. Well, x over 4, that's like 1/4. 1/4 is simplified, and this side is 1/2. That's also simplified, so we can't do anything there. But over here you'll notice, hey look, 2 over 10, it simplifies to 1 over 5. So again, I'm not really talking about this problem, but I just want to show you some of the differences. If I tell you to simplify the fractions and you're like, well, that doesn't mean anything, at least now you can see 2 over 10 simplifies to 1 over 5. That's what I mean by simplifying those fractions. Now what we're going to do is we're going to write the simplified factors. And it's literally as simple as parenthesis the top plus or minus the bottom. So 1x plus 4 and 1x plus 2. So what we've done is we've actually factored. We have taken it from the sum and written it as a product. Let me pause for a second and set this up to show you what I'm talking about. Original question. I kind of alluded to the fact that the x squared is pretty simple. We know where to put that in the box. And the 8 is pretty simple. We pretty much know where to put that in the box. But the question is, what's going to go on in here? We know it needs to add up to 6x, right? But should it be 6 and 0 or 5 and 1 or 4 and 2? So the diamond is what helps us determine that it should have been a 4 and a 2. So this should be 4x and this should be 2x. And what we have here is something that looks like this. X times x is x squared, x times 2 is 2x, x times 4 is 4x, 2 times 4 is 8, You can see I get x squared plus 6x plus 8. You can see it's x plus 2 times x plus 4, or x plus 4 times x plus 2, either way. So that's what this diamond did. It took us out of the area as a sum, and it helped us write the area as a product. And the entire reason that we're going to write the area as a product is what we can do is we can solve. We can say, hey, look, I want this thing to equal 0. Because if this equals 0, I'm going to get my y-intercept, and we'll talk about that in a minute. And if this thing equals 0, I'm going to get 0, and I'll have a y-intercept. So again, let me kind of set this up. Show you real quickly is that y equals x squared plus 6x plus 8 gives us a parabola. And then if I were to use the diamond to break it into the product, again, this is the sum, this is the product. There's x plus 4, x plus 2, x plus 4, x plus 2. You can see I get the exact same parabola. If you're wondering, like, well, hey, wait a minute, that other one had a 1 and this one didn't, you can see it doesn't change anything putting that 1 in there. It just means 1x, that means 1x, and that means 1x. So you can see I get the same parabola. But if you'll recall earlier, what I said is what we really want to focus on is in this chapter, chapter 4, we're going to focus on these x-intercepts. Don't forget, eventually we're going to worry about the y-intercept. That'll be in chapter 5, but not right yet. And eventually we'll worry about the vertex. Again, that'll be in chapter 5, but not yet. Right now, we're only concerned about these x-intercepts. How do I get a -2 and a -4 out of this? Well, that's the whole point. We're never going to get a -2 and a -4 out of it when it's written as a sum. That's kind of hard to see, but you can see there's a lot of like -4, -2, like there's something going on with the product that makes us think that it's not that far away from getting a -4 and a -2 out. So what exactly is going on here? Why did we go through the trouble of taking it as a sum and writing it as a product? Well, because if it's written as a product, it's really easy to get these x-intercepts, and then we'll know 2 of the really important points to help us solve this. So I'm going to go back over here and show you what I mean by that. So if I look here, here's what's happening in step 5. I'll kind of write this off to the side. So what's happening in step 5 is this. Essentially, I'm saying y equals 1x plus 4 and 1x plus 2. And I want to know where the x-intercepts are. Well, think about these x-intercepts. Okay, I don't know what the x is going to be, but I know that the y is going to be 0. I hope that makes sense. Like any points, any x-intercepts, that's true. I don't know what the x value is, but I know the y value is always 0 if it crosses the x-axis, right? The opposite is true for the y-intercept, but anyway. So hopefully we know enough about that basic algebra that I haven't lost you yet. So at this point, what I'm going to do is I'm going to say, hey, look, I know I want my y to equal 0. So what does my x have to be to make this equal true, right? I'm going to change this y to 0. And now the question is, what do I have to plug in here for x to make this whole thing equal 0? Well, look, we're multiplying. And anything times 0 equals 0. So if this left side equaled a billion, but the right side equals 0, a billion times 0 is 0. Well, if the left side equals 0 and the right side equaled a billion, a 0 times a billion equals 0. So how can I turn this into 0? I can just say 1x plus 4 needs to equal 0. And I get x equals -4. Or I can say, well, how do I make this equal 0? 1x plus 2 equals 0. So if I subtract 2 from each side, x equals -2. So if I go back into the original equation, look what happens if I plug -4 in. If I plug -4, 1 times -4 is -4 plus 4 is 0, right? I'm sort of solving this up. I'm going this way. Well, what is -4 plus 2? It's -2. And what is 0 times -2? It's 0. Hey, look, this is an x-intercept, right? If I plug -4 into this equation, the whole thing will turn into 0 and I'll have an x-intercept. Well, what if I go and I plug -2 in instead? Here I'll get -2 plus 4 times -2 plus 2. I'll get y equals 2 times 0. And guess what 2 times 0 is? It's also 0. So -4, 0 and -2, 0 must be my x-intercepts. Let's go look and see. Hey, look, -4, 0 and -2, 0. So that's what this last step entails. it essentially says, all right, well, when I have these intercepts, I'm just going to plug 0 in for the y, and I'm going to take this part of it and make it equal to 0 and see what I get, because if this part was 0, it wouldn't matter what this side was. And I'll do the same thing over here. I'll make this side equal 0 because it doesn't matter what this side is, because if this side's 0, anything times 0 is 0, and there will be my two x-intercepts. Now, I will say this, sometimes you can have a graph that looks like this and you'll have no x-intercepts, and sometimes you'll have a graph that looks like this and you'll have exactly one x-intercepts. Obviously, we had some that look like this where we had two x-intercepts in this one example. So just where we're going to be headed. So I hope this makes sense. At this point, I'm not really expecting you guys to have done much with this or to really fully contemplate what's happening. But I will go ahead and start doing some of these to see what we come up with. So let's go ahead and let's take out example 2 and let's replace example 2 with the following equation instead. And what we're going to do is we're going to go through these 5 steps and we're going to solve y equals x squared plus 7x plus 10. The first thing I'm going to do is initial factoring. Is there any number I can take out of 1, 7, and 10? And I hope you see that there is nothing I can take out, right? So I just still am left with y equals x squared plus 7x plus 10. The next thing I'm going to do is I'm going to set up my diamond. And I know that my diamond needs to have a times c on top, and it needs to have b on bottom. Well, my a is 1, my b is 7, and my c is 10. And again, I know that because ax squared plus bx plus c. So 1 times 10 is 10, and b is 7. 7's on the bottom. I'll go ahead and set up my sides, and it's ax. My a is 1, so it's just 1x on the sides. So I know I went through that fairly quickly, but hopefully that makes a lot of sense as to why we set it up the way we did. Now what I'm going to do is I'm going to say, all right, well, what numbers multiply to 10? 1 times 10 does, but I can't add or subtract that to get a 7. So I don't think that'll work. How about 2 and 5? And you'll notice I literally like to go in order from the smallest number to the biggest number. So 2 times 5 is 10, and 2 plus 5 is 7. So that works pretty well right there. I think 2 times 5 is 10, 2 plus 5 is 7. So I think those are my sides. Now I'm going to go to 3 and simplify these fractions if possible. Does 1/2 simplify? It does not. Does 1/5 simplify? It does not. Okay, so there's no simplifying going on. I'll go to step 4. I'm going to write the simplified factors, which is again 1x plus 2. And 1x plus 5. And now I'll use the factors to solve for the solution. So I'll set up 1x plus 4 equals 0. Over here I'm going to say 1x plus 2 is equal to 0. I'll solve that, and I get x equals negative 2. Well, think about it. My x is negative 2, and my y is 0. I already plugged this in at 0, right? I already plugged this in at 0. I said you need to equal 0. Why? Because I'm looking for the intercepts. Here, I'm going to get 1x plus 5 is equal to 0. I'll subtract 5 from each. So I'm going to get 1x equals negative 5. So again, my x is negative 5, but my y was 0. So these are going to be my two x-intercepts. So here's what I'm saying. I expect to see a shape that goes through negative 2, 0, and negative 5, 0. At this point, we've only dealt with those that open up, right? So I expect to see something that looks like this through negative 2, 0, and negative 5, 0. So let's go through and see what happens. If I graph y equals x squared plus 7x plus 10. If I graph y equals x squared plus 7x plus 10, it crosses at negative 2, 0, and it crosses at negative 5, 0. So just what we expected to see. So we should be pretty pleased about that. So this 5-step process allowed me to get my x-intercepts and to get that. So if right now, if you're freaking out and you're like, holy smokes, there's a lot going on here, that's fine. We're going to do this several times. So I don't want you guys freaking out thinking like, you know, you have to get it just this 1 second. So we'll spend a couple days on this. I'm going to pause and set up the next problem. We're going to solve is y equals 3x squared minus 5x plus 2. And again, the first thing that we'll do is we'll try and factor. Is there any number I can take out of a 3, a 5, and a 2? It looks like 1 would be the biggest, so I can't initially factor there. Maybe I'll put some of those in tomorrow's video, but we need to see that at some point. All right, the second thing is I'm going to set up my diamond. And again, I know my A is 3. I know my B is, it's not 5, it's a negative 5. And I know that my C is 2. So I'm going to say A times C on top, which is 3 times 2, which is 6. I'm going to say B on bottom, which is negative 5. And on the side, I'm going to put AX. Well, you can see my A is 3. So I'm going to get 3X on the sides. Now I need to, what numbers multiply to 6 and add to negative 5? Well, again, I like to go in order. So the first thing I'm going to do is say 1 times 6 is 6. Can I get a negative 5 out of here? What if I said this? 1 times negative 6 is negative 6, and 1 minus 6 is negative 5. So it looks like it wants to work, right? If I make it a positive, if I make them both positive, the top works, but the bottom adds to 7. If I make them negative, the bottom works because 1 minus 6 is minus 5, but the top doesn't work. So 1 and 6 must not be the answer. So let's try 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. So that doesn't work. What if I make 1 and negative? 2 times negative 3 is negative 6. That doesn't work. So maybe that they're both negative. A negative 2 times negative 3 is positive 6. A negative 2 plus a negative 3 is a negative 5. So it looks like these are going to be the two numbers I want on the side. Negative 2 and negative 3. Now I'm going to try and simplify. Can I simplify 3 over 2? I cannot. But can I simplify 3x over negative 3? Yeah, 3 goes into 3x once, and 3 goes into negative 3 negative 1 time. By the way, I always have kids try and skip this step. You can't skip this step. This step is really important. Otherwise, things get really confusing later on. So here's what I'm going to end up with. I'm going to say, again, I'll just write it as y as 0. I'm going to change my y to 0 right now because I know I'm going to look for the x-intercepts anyways. So 0 equals 3x minus 2. I'm literally just going to write it the way I see it. And this will be 1x minus 1. Now, how can I get my factors out of here? Well, I'll set them equal to 0. I'll say, all right, 3x minus 2 is equal to 0. I don't know what I did right there. And over here, I'm going to get 1x minus 1 is equal to 0. So I'll just use a little algebra. I'll add 2 to each side. I get 3x equals 2. I'll divide by 3. That'll cancel. So I'll get x equals 2/3. So I'll just sort of x equals 2/3. Well, if that's the case, my x is 2/3 and my y is 0. Here, I'll add 1 to both sides. So I'm going to get x equals 1. So this one should be 1, 0. So here's my x-intercepts, right? I should have 2/3 0 and 1, 0. So let's go graph 3x squared minus 5x plus 2, and let's see if we get x-intercepts at 2/3 0 and 1, 0. And here we go. You can see there's one at 1, 0, and you can see there's one at 0.667, which is obviously 2/3. So that also worked as well. If I zoom in a little bit, keep zooming in. Disaster. All right, so you can see I did get those x-intercepts using that 5-step process. So we're going to practice these 5 steps over and over until we get good at them.